Chapter 5, Section 2, Roots and Radicals. In this section, what we're going to do, and really for the remainder of the chapter, we're going to be dealing with square roots and cube roots. We're going to learn how to simplify them and multiply and divide and all kinds of things with these radicals. So, to square a number means to raise it to the second power, and we talked about this earlier in the chapter, or earlier in the semester. So if you have 4 squared, that's the same as 4 times 4, which is 16. Well, the opposite of a square is a square root. And so if you take 16 and you take the square root of it, you're going to get 4, which is what we started with here. So when you take the square root of a number, the answer is what can you multiply times itself to get 16? So the answer would be 4, but not only positive 4, but positive and negative 4, and we'll talk about that in just a minute. So some terminology that you're going to hear me talk about in this section and for the remainder of the chapter. When you see this symbol, this is a radical symbol. And the number underneath the radical sign is called the radicand. So for example here, the whole thing is called a radical expression. The number underneath here, the 16, that is your radicand. The entire expression is a radical, I already said that. There is a 2 that is understood to be in the upper left hand of the radical. So for example, the root here is 2, and we're going to be talking about different roots. These are called the indices, or the index. So the index of a square root is 2. The index of a cube root is 3. The index of a fourth root is 4. So the number here tells you what index, what root we're actually taking. Every positive real number has 2 square roots, one positive and one negative. And the reason being, and this is what I was saying earlier, when you take the square root of 16, you're going to get positive 4 and negative 4. So the square root of 16 is both positive 4 and negative 4. And like I said, this can be written as positive and negative like this. Reason being is because when you take 4 and you square it, you get 16. As well as if when you take negative 4 and you square it, you're going to get 16. Alright, and so negative real numbers have no real roots, and we are talking about real numbers here. Now in chapter 6, I think, we'll start talking about imaginary numbers, but right now, negative real numbers have no real square root, so you cannot take the square root of negative 16. And the reason being is because every time you square a number, you're going to get a positive answer, so you're never going to come up with a negative here and stay in the real numbers. The next one we're going to talk about is the cube of a number, and we talked about this early in the semester. To cube a number means 2 times 2 times 2 is equal to 8. Anything you can multiply times itself 3 times, that's cubing the number, and so 2 cubed is equal to 8. Well, the opposite of a cube is a cube root, and here is your index. In a cube root, the index is 3, and the cube root of 8, therefore, is 2. So you can take the cube root of a negative number, because if you do negative 2 cubed, that means negative 2 times negative 2 times negative 2, which is negative 8. So you can take the cube root of a negative number, but you cannot take the square root of a negative number. So to simplify a radical simply means that the radicand cannot contain a perfect power. So we're going to talk about 2 different number lists. One is going to be your perfect squares, and the other one's going to be your perfect cubes. So the first one we're going to talk about is the perfect squares. So what you're going to do is you're going to think of a perfect square. So what is a perfect square? Well, 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. 16 is a perfect square because 4 times 4 is 16. Anything basically that you can take the square root of is a perfect, and get a whole number is a perfect square. So 25 is a perfect square, and the list just goes on and on. We can go 6 times 6 is 36, so 36 is a perfect square. 7 times 7 is 49, so 49 is a perfect square. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144, and it just goes on and on and on. So this is a list, and you may want to write this list down on your index card for your test, because this is what you're going to think of. You're going to think of which of these numbers, which of your perfect squares will go into your radicand. That's your first step in simplifying a radical. And then what you're going to do is you're going to write the product of the perfect square. So let's think of one. Let's say the square root of 24. And we're going to simplify this. So my first step would be think of a perfect square factor for the radicand. Well, which of these numbers in this list will go into 24? And your answer is 4. So there's your perfect square. That's step number 1. Step number 2, you're going to write the product, basically a multiplication problem of your perfect square and the other factor. So 4 times what is 24? 4 times 6. And then step number 3, what you're going to do is you're going to take the square root of the 4 and bring it out as a 2, because the square root of 4 is 2. So we're going to bring it out from underneath the radical, but you can't take the square root of 6 and get a whole number, so it has to stay under. So the simplification of the square root of 24 is 2 square roots of 6. And this is multiplication. This says 2 times the square root of 6. So let's try this again. What perfect square will go into 54? And I think it's going to be 9, and 9 times what gives you 54? 9 times 6. So what you're going to do is you're going to split these two up. You can take them apart, because a radical times a radical is still a radical. So for example, and we'll learn this later on in the chapter, but you'll already know it when you get there. So the square root of 9 times the square root of 6 is the square root of 54. So if you actually take the square root of 9, you're going to get 3. The radical sign goes away. Anytime you use the radical sign, that goes away. So, for example, if you do 3 minus, 1, you're going to get 2, and the minus sign goes away. Well, the same thing. When you take the square root of 9, the square root symbol goes away, letting me know that you took the square root of 9 to get 3, but you can't take the square root of 6 to get a whole number, so you just leave the square root of 6. Alright, so for the square root of 63, it's going to be 9 times 7. Square root of 9 is 3, so it's going to come out, and you can't take the square root of 7 and get a whole number, so it has to stay under. Square root of 300, there are 2 perfect squares that will go into 300. It's 100 and 25. You always want to go with the highest perfect square, so that you don't have to worry about taking the square root again. So 100 times 3. And the square root of 100 is going to be 10, and you can't take the square root of 3, so that has to stay under. So what happens if you don't take the biggest perfect square? So for example, if we take the square root of 300, and we use 25. Well, the multiplication problem turns into 25 times 12, and we take the square root of 25, which is going to be 5 square roots of 12. This is not simplified because 12 has a perfect square power, and that's step number 4. Look to see if the remaining radicand has a perfect square factor. Well, 12 does. It has a 4 in it, so you're going to have to go again. And understand that this is multiplication, so this is 5 times, 12 is going to break down into 4 times 3, and the square root of 4 is 2, so it's going to come out, and 3 has to stay under, and then you have to finish your multiplication and get 10 square roots of 3. So you'll get the same answer, but you just have to remember to keep going. So if you don't pick the highest perfect square, just understand that you're going to have to keep going. Alright, cubes. So the cube list is going to be 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And the next one's going to be 64. And then the next one's going to be 125. And again, this list just keeps going. So you may want to make that list on your card. So you're going to do the exact same process, but you're just going to use this list because now we have an index of 3. And so that tells me that I have to use the perfect cube list instead of the perfect square list. So which of these numbers will go into 56? And that's going to be 8. And it's going to be 8 times 7. So the cube root of 8 is going to be 2. So that's going to come out. And you can't take the cube root of 7. So that's going to stay under. Alright, 108. Let's do 108 divided by 27. So yeah, it's going to be 27 and 4. So we're going to have the cube root of 27 times 4. And the cube root of 27 is 3, so you have 3 cube roots of 4. And then 81, I think 81 is going to be 27 again. 81 divided by 27. So we're going to get the cube root of 27 times 3. And then again, the cube root of 27 is 3, so that's going to come out. And you can't take the cube root of 3, so that one's going to stay under. So that's how you do perfect squares, how you simplify square roots and cube roots. The next thing we're going to do is we're going to learn how to deal with fractions. So a radical is said to be in simplest radical form if the following conditions are satisfied. And when you are taking your test, every answer that you write down, I want you to take the time to check your answer against these 3 rules, basically. So number 1, you cannot have a fraction underneath the radical. So in other words, you cannot have something like 4/7, the square root of 4/7. You can't do that, so we're going to have to fix that, and I'll show you how to do that in a minute. You cannot have a radical in the denominator, so you can't have something like 3 over the square root of 5. You see how we have a radical in the denominator? So you can't have that either. And then number 3 takes care of what we did in the previous couple of slides. No radicand contains a factor raised to a power equal to or greater than the index. All that means is you can't have a perfect square or you can't have a perfect cube still underneath your radical. You have to keep simplifying. And that's what we're doing. We are simplifying these. So, how do we take care of these fractions? The first thing, to simplify a radical with a fraction as the radicand or a fraction with a radical in the denominator. What you're going to do is you're going to simplify your radicals where you can, and then you're going to multiply the numerator and the denominator by the radical that you want to get rid of in the denominator. So, for example, let's take this very first one. I can't have a fraction underneath the radical, so what I'm going to do is I'm going to split these up. If you have a fraction underneath the radical, split them up, and you make a division problem out of it. Just like we'd made a multiplication problem out of these, you're going to make a division problem out of these. And then simplify. The square root of 4 is just 2, and you can't take the square root of 7. So that fixed the problem of having a radical underneath have a fraction underneath the radical, but step number 2, or rule number 2, is still broken in that we have a radical in the denominator. So how are we going to fix this? Well, we need this radical to turn into a perfect square. So what can you multiply 7 by in order to get a perfect square? And I'm thinking 7 times 7 is 49. So what we're going to do is we're going to multiply the top and the bottom by the square root of 7 to get us on that perfect square list, because 7 times 7 is going to be 49. Now, one word of caution here, and like I said, we will talk about this more later on in the chapter, but you're already going to know how to do it when we get there, so just remember this. You cannot multiply whole numbers times radicals. Radicals, if you can't take the square root of a number, it's going to be some decimal. So if you put the square root of 7 in your calculator, you're going to get some decimal. So this is not 2 times 7. This is 2 times some decimal. So you can't multiply 2 times, or you can't multiply any whole number times a square root or a cube root, just any radical. You can't multiply a whole number times a radical unless you come up with a decimal, and we don't ever want to come up with decimals in this. So, how do you write this? Well, 2 times the square root of 7 is simply 2 square roots of 7, 2 times the square root of 7. What you can multiply together is a radical times a radical. So the square root of 7 times the square root of 7 is the square root of 49. And that's how we're going to get that radical out of the denominator, because 2 square roots of 7, you can't do anything with it, because if you do, you're going to get a decimal. But if you take the square root of 49, you're going to get a whole number of 7. So that's how you're going to fix those fractions. So let's look at this one. For this particular problem, we cannot simplify the radicals. We can't reduce anything of this because there's not a perfect square that goes into 3, and there's not a perfect square that goes into 6. So what we're going to do is I'm going to show you 2 ways to do this problem, and you can go either way that you want to. I just don't want you to get confused. So I'm going to multiply the square root of 6, actually I'm going to multiply this whole entire fraction by a number that's going to make square root of 6 a perfect square. So if I multiply the square root of 6 times the square root of 6, that's going to give me the square root of 36, which is a perfect square, and that's what I need. So we're going to multiply the top and the bottom by the square root of 6. So the top is going to multiply into 4 square roots of 3 times the square root of 6 is going to be 4 square roots of 18. Remember, you cannot mix whole numbers and radicals. You cannot mix whole numbers and radicals. So you're going to get 4 times, and you're going to combine these, multiply these, so square root of 18 over the square root of 36. And don't reduce this, because if you try to reduce the square root of 18 and the square root of 36, it's going to take you right back to the beginning. So you're just going to be like a dog chasing its tail, going around and around. So don't do that. Instead, what we're going to do is we're going to simplify this. So the square root of 18 will go into 9 times 2, and the square root of 36 will simply go to 6. So to simplify the top even further, we're going to have 4 times the square root of 9 is 3, so we're going to bring that out. Square roots of 2 over 6. Go ahead and keep simplifying, so we're going to have 12 square roots of 2 over 6. And now the whole numbers here we can reduce. So when you get to the end, the only thing that you can reduce are the whole numbers. So 6 will go into itself 1 time, and 6 will go into 12 2 times. So your answer is going to be 2 square roots of 2. So what is the other way? Well, I don't want you to mess this up, but I am going to show this to you because it is easier. Just like here, you can reduce your whole numbers. The 12 and the 6 will reduce. Well, at the very beginning of the problem, you can also reduce radicals. So I'm just going to rewrite this here. 4 square roots of 3 over the square root of 6. Like I said, just like you can reduce whole numbers, you can also reduce radicals. So the 3 will go into itself 1 time, and 3 will go into 6 2 times. So what we have, now the radicals don't go away because you're still dealing with radicals. So you have 4 square roots of 1 over the square root of 2. Simplify where you can. So if the square root of 1 is just 1, so you have 4 times 1, which is going to be 4 over the square root of 2. So you still have the problem of having the radical in the denominator. So we'll multiply the top and the bottom by the square root of 2, because the square root of 2 times the square root of 2 is going to be 4, which is a perfect square, and that's what I need. So on top, we're just going to get 4 square roots of 2 over square root of 2 times square root of 2 is the square root of 4. Don't reduce here. Don't reduce until you get to the end. Square root of 4 is 2. So this 2, whole number and whole number, will cancel this 4. And so you get 2 square roots of 2. And you can see that you get the same answer either way. So it's just whatever you can keep straight in your head. And the trick is knowing when you can reduce and when you cannot reduce. So like here, if you reduce this, it's just going to take you back here. So you don't want to do that. So let's look at this one. This one, you have a fraction underneath the radical, so the very first thing you want to do is you want to split it up. So we're going to have the square root of 9 over the square root of 5. Square root of 9 is just 3, so we'll have 3 over the square root of 5. So now I've got to get rid of that radical in the denominator, and the way I'm going to do that is I want the square root of 5 to turn into a perfect square. So 5 times 5 is 25, so we're going to multiply the top and the bottom by the square root of 5. And 25 is a perfect square. So 3 times square root of 5 is 3 square roots of 5. And square root of 5 times square root of 5 is the square root of 25. Remember how you multiply whole numbers and radicals. You cannot mix the whole numbers with radicals, but you can multiply radical times radical. Don't reduce here. Keep on simplifying. So we're going to have 3 square roots of 5 over the square root of 25 is 5. And the 3 and the 5, this one, the 3 and the 5 won't reduce, so this is going to be your answer. Alright, so let's look at this problem. 5 and 3, the whole numbers will not reduce, but the 18 and the 12, 18 will reduce, 18 and 12 both will reduce by 6. So 6 will go into 18 3 times, and 6 will go into 12 2 times. So let's turn that into 5 square roots of 3 over 3 square roots of 2. Alright, so now what I need to do is I need to get that square root of 2 out of the denominator. So I'm going to multiply the top and the bottom by the square root of 2 so that on the bottom I get the square root of 4. And again, remember, you can't multiply your whole numbers and your radicals, so we're going to do 5. Can't do anything with a 5. But the square root of 3 times the square root of 2 is the square root of 6. And then you can't do anything with the whole number of 3, but the square root of 2 times the square root of 2 is the square root of 4. Don't reduce here. The best advice I can give you is you can reduce at the beginning and you can reduce at the end, but never in between. So now we're going to take the square root of 4 and get 3. Instead of 3 times the square root of 4, we're going to get 3 times 2. So we'll have 5 square roots of 6 over 6. And this won't reduce because the whole numbers of 5 and 6 won't reduce, and you cannot reduce a radical with a whole number. So that is going to be your answer. Alright, the one on the bottom, I'm going to go ahead and fix this 12. 12 will turn into 4 times 3. So I can't do anything with the top, so it's just going to stay as is, but I am going to simplify this radical in the denominator. So that's going to turn into 5 times 2 times the square root of 3. So, alright, so we've got the 12 simplified, and you don't have to do that. If you want to go ahead and start off by multiplying the top and the bottom by the square root of 12 and then simplifying at the end, that's fine. But I don't like dealing with those big numbers, so I'd rather have a smaller number to start with. But like I said, if you want to start by multiplying by the top and the bottom by the square root of 12, that's fine. So now what I'm going to do is I'm going to multiply the square root of 3 by something that's going to give me a perfect square. So the square root of 3 times the square root of 3 is going to be 9. So 9 is a perfect square. So the top and the bottom. So on the top I'm going to get 6 square roots of 15. And on the bottom I'm going to get 10 square roots of 9. So if we keep going, we're going to get 6 square roots of 15 over 10 times 3. Instead of 10 times the square root of 9, we're going to get 10 times 3. So now I'm going to have 6 square roots of 15 over 30. And the 6 and the 30 will reduce. 6 will go into itself 1 time, and 6 will go into 35 times. So I have the square root of 15 over 5. Square root of 15 over 5. And that will not reduce because one is a radical and the other one is not. Cubes. Same process. Cube root of 2 and the cube root of 9. These will not reduce. 2 won't go into 9. So what I need to do is I need to think, what can I multiply 9 by in order to get me on that perfect cube list? Remember that list is 8. You should have it written down somewhere. 8, 27, 64, 125, and on and on and on. So what can I multiply 9 by in order to get something on this list? If I multiply 9 times 3, that's going to give me 27. So this time we're going to multiply by the cube root. You have to stay in the same root, same index. So the cube root of 3 on top and bottom. So the cube root of 2 times the cube root of 3 is going to be the cube root of 6. And the cube root of 9 times the cube root of 3 is the cube root of 27. Can't take the cube root of 6, but the cube root of 27 is 3. And again, you cannot reduce here because you cannot mix whole numbers with radicals. Again, this is a decimal. Okay, on the last one, cube root of 8 over the cube root of 16. Well, like we did with the square roots, we can reduce this. Cube root 8 will go into itself 1 time. 8 will go into 16 2 times. So now what you're going to have is the cube root of 1 over the cube root of 2. So remember, when you reduce, you can't take them out from under the radical yet because we haven't done anything with that. The cube root of 1 is 1, so that radical is going to go away, but the cube root of 2 won't. So now I have to think, what can I multiply 2 by in order to get on this list? And I'm thinking 8, so cube root of 4. So 1 times the cube root of 4 is the cube root of 4. And the cube root of 2 times the cube root of 4 is going to be the cube root of 8. Don't reduce here, because if you do that, if you reduce these two like we did in the beginning, it's just going to take you back to here. So remember, reduce at the beginning and reduce at the end, but not in between. So now we're going to have the cube root of 4 over cube root of 8 is 2. You can't simplify these because one's a radical and one's not. Alright, the only reason why I wanted to show you this problem is because I know fractions kind of make people nervous, but this is not that bad. The very beginning, when I showed you how to simplify a radical, what you're going to do is you're going to take 150 and you're going to simplify it into 25 times 7. I'm sorry, times 6. 25 times 6. And then you're going to have the square root of 25 is going to be 5. And you can't do anything with a 6. So now you're just going to multiply in your calculator 3/4 times 5, which is going to give you 15/4 square root of 6. And I don't want you to change that to a mixed number. I'd rather you leave it as an improper fraction, and you'll understand why as we go through this chapter. Alright, so I'd like you to try these problems on page 259. Bring them into class if you have any problems.